Hello, welcome to my video, and today we'll be talking about line segments. Line segments are... So what is a line segment? Line segments are usually passed between 2 points with a fixed length, as you can see here. So one thing that we usually do with line segments is we usually calculate the distance between 2 points. So in this graph, we can see we have the points A and points B. So A has the points minus 5, 5, and B has the point 1 and 4. And when we want to calculate the distance between 2 points, we use this formula here. So D is equal to x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. And all of this is square rooted. So as we continue on to the equation, and now for this question, we want to find the distance between point A and B. So we would put the points into the equation. So imagine our x2 and y2 is point A, so minus 5, 5, and our x1, y1 will be the points 1 and 4. Or you can do this the other way around. It really doesn't matter because when we square it, everything will become positive at the end. So as we go on to our equation, x2, so it'll be minus 5 minus x1 minus 1 all to the power of 2 plus y2 5 minus y1 4 5 minus 4 all to the power of 2. As we go on, we'll see minus 5 minus 1 is minus 6 all to the power of 2 plus 5 minus 4 all to the power of 2 is 1 squared. So minus 6 to the power of 2 becomes 36 plus y to the power of 2 becomes 1, and we get d is equal to the root 37, or if we wanted to put it in decimal form, d is equal to 6.08. So now we can see how distance formula is used. Let's do actual questions on this and practice. So as you can see here, the first question we get is find the distance between point A and point B. Now we can see A is 2, 5 and B is 4, 3. So if we wanted to do this, I want you to first do this on your own, pause the video and see the answers after. So now what we're going to do is we're going to use the formula again. D is equal to x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. Okay, so right now our A will be x2, y2, and our B will be x1, y1. And again, you can use whatever, you can make whatever x2, y2 you want because it'll become the same thing at the end. So now we can see x2 will do 2 minus 4 all to the power of 2 plus y2 5 minus 3 squared. And this will become minus 2 squared plus 5 minus 3, 2 squared. Okay? And then this will become minus 4 plus 4, and then we can go. We'll get 8, and then this will become this will become 2 root 2 first. So this is our one form we can put in, or D is equal to 2.82. So this was one of the questions. Now the second one. Now we have B. Our A is equal to minus 6, 5, and B is 5, 7. Now pause the video again and do it on, first try it on your own. So what's going to happen now is D is equal to, again, x2 minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. Now again, we can make these points. So here, for A, we'll make this x1, y1. We're changing it a bit. and this will be x2, y2. So as we go into the equation, we can see x2, so 5 minus 6 squared, okay, and y2, which is 7 minus 5 squared. As we continue on, we'll get 11 squared plus 2 squared, and as we continue on, sorry about the space, 121 plus 4. And then this will give us 125, which just becomes 5 root 5, or 11.18. So at the end, the distance between point A and point B is equal to 5 root 5, or 11.18. Now, let's go back to the first page, and we'll do this question. So given the vertices at point 4, A, 4 minus 3, B, minus 2, 6, and C, 5, 2, what kind of triangle do they form? Now, we know several triangles that could form in this problem. So I want you to see here that there are several different types of triangles that could be formed. We have a scalene triangle where all sides are different lengths. All lengths and angles are different. So in this triangle, we can see one side is 6, 7, 8, and there's different angles to each side, which shows that this is a scalene triangle. And this is why distance formula is so important, because we can also find out what kind of triangle we're forming. Or we can form an isosceles triangle where two sides, like here, are equal and one side is like a different length, and all sides add up to 180 like usual. Or it could be a equilateral triangle where all sides are the same length and all angles are 60 degrees. Now let's continue on with this question. So now we see, given the vertices at point given the vertices at point A 4 minus 3, B minus 2 6, and 5 C 5 2, what kind of triangle do they form? Now let's actually put these points into the graph. So we're just going to imagine each dot is 1, right? So A 4 3, so 1 2 3 4 minus 3, 1 2 3, A would be here, right? B minus 2 6, so minus 1 minus 2, 1 2 3 4 5 6, right? This would be our B. And C 5 2, 1 2 3 4 5, and 1 2. This is our C. Okay, so now what we have to do is we're going to add all the lines together. So this is not exactly straight, but now we get this. So if I want you to imagine first what the triangle may be. So would it, from the options I gave here, would it be a scalene, an isosceles, or equilateral? Now, as we continue on with this question, I would imagine it's a scalene, but let's continue. So when we want to find the kind of triangle, we want to find the distance between each side length. So imagine we find the distance between AB, BC, CA, and then from there we'll find what kind of triangle it is. So let's first do it with AB. AB, we know x2 minus x1 squared plus y2 minus y1 squared, right? So let's make this here. Our x2 will be x1 will be x2, y2 will be A, and x2, yeah, and x1, y1 will be B. Okay, so here our x2 will do 4 minus 2 all to the power of 2 plus minus 3 minus 6 all to the power of 2, right? So then what's going to happen is, so 4 minus 2 will become 4 plus 2, which is 6 squared, plus minus 3 minus 6 squared, which is minus 9 squared. So that will become, since 6 times 6 is 36, plus minus 9 squared is 81. So we get 36 plus 81. Now, 36 plus 81 is equal to 117. So we get 1 root. Now we're just going to keep it like that because we want everything to be rounded to a good point. So now now we know the point distance between A and B. So we can just put it into a graph to make it easier for later. Right? Now let's find the point between A and C. Okay? So now I'm not going to put we're going to put the equation again. Right? So we're going to keep A as x2, y2, and C as x1, y1. So what's going to happen now is x2, which will be 4 minus 5 squared, plus y2, which is minus 3 minus 2 squared. So 4 minus 5 will become minus 1 squared, plus minus 3 minus 2 will become minus 5 squared. And this whole thing, so minus 1 squared will become positive 1, and minus 5 squared will become 25. And this whole thing will equal root 26. So we now know the distance between AC is equal to root 26. And now we can put this into our equation. Okay, so now that we know this, we still need to find the distance between B and C. So now what we do is again find the distance between these 2 points. Now if you want to practice yourself, you can pause the video and try it on your own. But here's also how we will do it. Sorry, x2 minus x1 squared plus y2 minus y1 squared. Okay, so BC, right here we'll make B into our x2, y2, and C into x1, y1. So here, what we do, x2 minus 2 minus 1, so minus 5, all to the power of 2, plus y2, 6 minus 2 squared. So this will equal minus 7 squared plus 6 minus 2, which is 4 squared. And this will become 49 plus 16, and that will equal root 65. And we can just put this back into our triangle. Now, when you see this triangle, you can see how all sides are different. Like, we don't have any side that's all root 65 or 2 sides that are the same length. So what we can identify with this triangle is that this type of triangle, so if we go back to our paper or page on the types of triangles, it could be either a scaling triangle, since all side lengths are different, isosceles, or equilateral triangle. But as we see in this paper here, all sides are different lengths. So this therefore will be a scaling triangle. So if we write our therefore statement, therefore the triangle of A, B, and C is a scaling triangle. So we have our therefore statement. Now if we wanted to continue on with our questions, so let's do this question. So this question is asking the distance between 2 points is 5 if one coordinate is 4, 3 and the other is x minus 1, find x. So from this equation we can again make x2 minus x1 squared plus y2 minus y1 squared. Right? So what do we know from the question given? We know that the distance already, which is 5, so we can just put it in. And let's assume this is our x2, y2, and this is our x1, y1. Right? So we know our x2, so we can just put it into the formula. But we don't know x, so we just do this. And then y2, 3 minus 1 all squared, right? So after, what happens is we get 5, 4 minus x squared plus 4 squared. And then after that, we'll be left with 5, 4 minus x squared plus 16. So now you may be thinking, how are we going to isolate the x to find what x is? Well, one thing we can do is square both sides to the power of 2, because this will cancel out the square root, right? And whatever you do to the left one side, you have to do to the other. So now we're going to have 25 is equal, so this cancels out, 4 minus x all to the power of 2 plus 16. So now what happens is we need to bring this to the other side. So what we can do is minus 16 from both sides. Okay, and then we'll be left, so this will cancel out. And 9 is equal to 4 minus x squared. Now, since we know if you square roots, when you have a square root and you do it to the power of 2, it cancels out. We can do the same thing here. So now what happens is, so 3 equals 4 minus x. Right? So one thing that we should notice is that this is a positive 9. Now there's two ways. So square root of 9 is 3. However, it could be two different ways. We can show our 3, like minus 3 squared, which is minus 3 times minus 3, or 3 squared, which is 3 times 3. Either way, both equals 9. So we don't specifically know if our 3 is going to be a positive or minus. So we do plus or minus 3. And then to find x, we would do 3 equals 4 minus x, or minus 3 equals 4 minus x. Now let's isolate for x. So what we can do is we can add x on both sides. And minus 3 on both sides. So what will happen? 3 and minus 3 will cancel out, and minus x plus x will also cancel out. So then we'll be left with x is equal to 1, or if we do the same thing here, plus x minus plus 3, and here plus x plus 3 cancels out, then x is going to equal 7. So now we know therefore, so x could be equal 1 or 7. So for our therefore statement, therefore the point x1, y1 will be either 1 minus 1 or 7 minus 1. So that's all for today. I hope you enjoyed my video, and bye.